Hi everyone, Twin Beard back in the Pirate Broadcast Lab. A couple things to show you today. I've been working on the flowerpower version 2 a little bit. I'll show you what we got set up over there. Also got a new scope probe. I got this Gauss meter, magnetic field probe. It's good from 2 kilohertz to 1 megahertz. 1 millivolt AC per milligauss. Thought that was kind of spiffy. So we'll play with that a little bit. But for the moment, I want to show you, got a bifilar coil here. You can see the relative thickness of it there. It's wound of number 29 and number 30. Wound bifilar. Then I tap 2 ends together there to run them into series outer phase. And we got that as the earth lead, and then this other lead is the positive lead. And that coil is completely surrounding this spherical magnet. I think that's a 1/2 incher that I have in there. Maybe a 3/8. Yeah, it is a 3/8 if I remember right. These batteries are really nothing. They're just kind of holding these 2 plastic pieces that are holding the coil in place there. But now take a look at the scope trace that's coming off of this. We're set at 0.1 milliseconds or 100 microseconds per division there. And we're at 200 volts per division. And what it looks like I'm seeing is here we have the sinusoidal wave that represents the magnet rotating. So that's about I don't know, 350 volts or so that's coming off of that. 400 volts, somewhere around there. But then this trace here, this ring, occurs in conjunction with the scalar discharge from the drive coil, power coil pair. So when that magnetic field collapses and unleashes that scalar impulse, that makes this generator coil ring at what looks like about 120 kilocycles, somewhere around there, 130 kilocycles. If we look at all the alternations back and forth here, all the ring downs, that's kind of the frequency that's ringing at. So okay, I'm going to kind of tear this apart a little bit and we'll play with it some. Just going to remove the generator coil. And bring it over here. On the other side I had this argon bulb on the end of the clip lead, and it was sliding it 1 wire style. So as you can see, this guy's boogieing pretty well. I'm going to clock him at about, well, let's see. We were on 1 millisecond per division. No. 0.1 milliseconds per division. 4 divisions wide, peak to peak. Pulse to pulse. So that's about 2,500 hertz, somewhere around there. Not really a lot of heat there. I got some lubricant. Just been hitting it with a shot of WD-40 every now and again. But, for the demonstration of the Gauss meter, I'm going to go ahead and pull the rotor here. Let it spin down on its own. Shut down power to the machine. And I think that's called the extended spin down. So what I did pretty much was I took this piece of tubing that I have. Let me grab the big piece of tubing. Here's the tubing. And I cut a chunk off. I cut some slats in it. I put a zip tie through there with the magnet in the middle, and then I kind of zap it every now and again with WD-40 or so. Okay, so for the next demonstration, we're going to play with the Gauss meter a little bit. You can see we also have voltage meter, current meter connected to this device on the input. So I'm just going to lay this guy down here. This is kind of a little funky Teflon housing. This is a little bit smaller magnet. This might be the 3/8. I think that we had the 1/4 in there originally. But I'm just going to drop it down in there and let it go about its merry business as it goes. So I'm going to zero out my gain pots, flip it on, and it went to self-resonation there. You can see it's drawing about a, I don't know, 9/10 of an amp of current. But just a little added base resistance takes care of that. Takes it out of resonance. Okay, I've got here my starter motor. This is another Bedini coil with a 1-inch magnet and a rotor housing in there. And it's right in the middle, so it starts every time real easy. And it's connected to this circuit over here. So what I'm going to do is I'm going to give this a... First I'm going to turn it on. It doesn't work well without being turned on. I'm going to give it a spin. Oop. May need to give it a lube too. It's been a while since I've had to use it. Spread a little WD in there. And give it a spin up. I'm going to use it like so. Jump started this one. Now this one's spinning. So I can shut this guy off. Put him back over there. Now I'm going to tune this machine up. Now all I'm varying here is base resistance, okay? I'm not varying my I'm not varying my rotor position here. It's just kind of sitting in there spinning. So I'm going to tune for minimum current draw, and maybe if I lube it here just a shade. You can see the gas that's being extruded off of that as it atomizes the lubricant. I think that's about the best we're going to get. Somewhere around 0.6 of an amp with this particular rotor. So let's take a look at our waveform here. Not using the generator coil at this point. I've got a 100 times probe here, and I'm going to take this ground lead, and I'm going to clip it to my negative output. I would connect that to the negative terminal of a battery that I was charging, and I'm going to connect the positive of the trace over here. Okay, so we're set up on 20 volts per division here for a 10 times probe, but this is a 100 times probe, so that's 200 volts per division. So we have spikes of 100, or of 200, 400, and 80, it looks like. And I'm pretty sure that if I tune some, I can improve that. Yeah, there we go. So now we have spikes of about 520 volts, somewhere in that neighborhood. Okay? And that's from the collapse of this coil. You can also see we're at 0.1 milliseconds per division here. So we have, say a little better than 4. A little better than 5 divisions between peaks. So that's 2,000 hertz per, essentially. Or we're at, so we're doing a little better than 2,000 hertz. Because 2,000 hertz would be 5 divisions wide. So we're doing a little better than that. And that kind of can be verified by the audible tone. Okay, but the reason I pulled it out into this configuration from the other configuration is so you can see the effect of the Gauss meter probe and what the scope trace looks like on that. So let me go to alternate channels here. Center this up. I'm just going to put the Gauss meter right on top of here. So it's going to get both the field from the magnet if I can get her to balance correctly. There we go. The field from the magnet and the field from the coil. Now the magnet is rotating pole over pole. It's rotating on a Y plane. And that Y plane is rotating around the Z plane, or the Z axis rather. So it's spinning this way, but then it precesses. So then it spins this way, this way, this way, this way, back to this way. Okay, so you can see minor variations in that in this trace here. We're at 5 volts per division. Okay, so we're seeing essentially 5 Gauss there. I'm going to take it to 2 so you can see it a little better. This is the collapse spike right here, approaching 500 volts. If we look real close, we'll see that this event happens first by minute periods of time. And this is the actual collapse of the magnetic field happening. Okay? The wave here. We see at this point the transistor switches on, rise time, hold time, fall time, collapse of the field, and there we go. till collapse produces voltage. In case you wondered what all that was, it 10 times mag, then I switched back and forth. Maybe you saw it. This camera might be wide enough, I don't know. Switching between channel 1 and channel 2 triggering. And normal triggering, which I find kind of odd. Gotta put low frequency reject on or it's not happy. So there it is, boys and girls. The Gauss meter over the rotating magnet. And then I'll just kind of wave it around a little bit like this so you can see what happens, okay? While watching the scope. So the collapse spike isn't anywhere near as strong out in the side as when we get into the middle. Okay, so for the purposes of that demonstration, showing the change in magnetic field there, that part's done. But I want to show you this too, because this is pretty spiffy. Just put it on a little riser there, okay? I'm going to tuck it down a little further. Like so. And give it a kickstart. Start a motor on. Give it a spin up. Bring it over here near the target. Oops. Stall this guy out somehow. We're a little greedy. Back in the day when no one cared, sitting in our basements, face it, hacking on computers, disassembling stuff, paid off in the end. Sounds like it's got some corrupt in there with it. Needs to be cleaned out. In the world of the Switch, make a new generation of us geeksters rich. We own those that made fun of us. That's the satellite effect, I call it. You just have to get it up magnetic gearing to get this one spinning fast enough to trigger the coil. And there we go. And what I want to show here is how this guy can really achieve some high velocity. Gym, cause I never was athletic. I played a couple sports just to keep it copacetic. By changing the rotor position in relation to the drive coil. Every time I rode a go-to bitch, I had that baby looping. Basically, basic was the first language I spoke, and I was telling. As you can see, we're on the same 1 microsecond per division here. But we push it up so we only have, or 0.1 milliseconds rather per division. But we pushed it forward so that we only have, what, 3 divisions in between instead of 5, almost 5. 1 division is 10,000 hertz, 2 divisions is 5,000 hertz. 4 divisions is 2,500. Halfway in between 3,750. So we increased the RPMs almost double by that little action right there. Finding the proper magnetic gearing sweet spot in relation to the coil, and the size of the field coming off the coil, and the size of the field of the magnet. There's a point where it meshes together. And right now we're pretty close to that point. Now it's drawing a lot of power to do that. Let's push it up over a little over an amp.
Dans lequel je vivais avant, cela fait maintenant plus de 10 ans qu'avec papa et maman, mes frères et mes sœurs, on a quitté nos champs, on est venus s'entasser dans une de ces cabanes à l'entrée de la ville. C'est papa qui l'a construite, mais elle est pas finie. Je n'ai que des vagues souvenirs du village. Maman pleure quand elle m'en parle, car elle n'aime pas la vie ici. Des étrangers ont brûlé nos maisons pour nous voler nos terres. Papa s'énerve, moi je comprends pas, il parle d'agroalimentaire. Il dit que les politiques sont des prédateurs qui sèment la peur et qui ont un estomac à la place du cœur. Ici pas de travail, aucune prière ne
see, at this point we can introduce this coil if we really want to.
Mais malgré tous ces efforts, demeure ces jours sans repas. La nuit maman pleure, la nuit maman ne dort pas.
Let me see what our trace looks like on that.
M'a dit pendant la dictature c'était plus dur, alors je vais pas me plaindre même si
ici
y a pas de futur. Moi j'aime bien les études, on m'a dit c'est bien mais inutile, ici beaucoup ont arrêté avant même de savoir écrire. Dans mon jardin secret je cultive le rêve d'être médecin, soigner tous ces enfants malades qui ne mangent pas à leur faim. Je comprends pas, dans la ville je vois bien tous ces petits faire la manche devant le mépris de ceux qu'on appelle les gens bien. Je m'interroge, ne voient-ils pas la misère? Ils nous écrasent pour bénir l'homme venant de l'autre hémisphère. Papa dit qu'on est traités comme des chiens. Dieu merci, j'ai ma famille.
Be amazed how peculiar these guys are when it comes to the alignment of things. Geometrical alignment of the components of the devices. Okay, so here's what our trace looks like once again. We've got an AC waveform that's being torn up by this ringing. As soon as that spike hits, boom. You can examine a little bit the field that's around this even. You can see it rings as well. That's what we're looking for, guys. Resonance of the ether. Hope you enjoyed my presentation tonight, ladies and gentlemen. Like I said, just been working on a few things, and I got the new scope probe here. Wanted to show you guys. These are handy to have around as well. Check out